This lesson is for Advanced Algebra, Lesson 10.6 on graphing with cosine and sine. Students will only be allowed to use a baby calc in these instances. What I've done here is I've combined both a table of values with a graph. So here's your y-axis and here's your x-axis. We're going to take the unit circle and we're going to graph two graphs that are called sine waves. And we'll talk a little bit more about that later in the video. So the shape of both the cosine and the sine graph are referred to as sine wave shaped graphs. We're going to do a little quick review of the unit circle. Remember that when you go around the unit circle, remember that you start at the point 1, 0, which is at 0 degrees. And as you travel positively around the circle, which is the clockwise direction, you're going to end up hitting a point like 90 degrees, and that coordinate is at 0, 1. Then when you travel around to here, you end up at 180 degrees. That coordinate is at negative 1, 0. And then you travel down here to 270, which is at the point 0, negative 1, and then you're back to the start. Those are the coordinates we're going to utilize today to graph, but know that there are other points in between that we're kind of ignoring or skipping for now. As we travel around the unit circle, remember that the cosine is the x value and the sine is the y value. So what we're going to do as we travel around the circle, we're going to graph just the x values as we go to different degree measures. Then we're going to go around again and we're going to grab just the y values and we're going to graph those. So let's talk about doing the cosine at 0 degrees. Cosine at 0 degrees is the x value at this location, so that would be a 1. Then the cosine at 90 degrees is the x value here, which is 0. And then as we keep maneuvering around the circle, we're going to end up with negative 1, 0, back to 1. So keep in mind that these numbers here are all in degrees. Now let's go ahead and graph these coordinates and see if we get this sine wave that we're looking for. So 0, 1, I need to find where my 1 is on my graph here. I'm just going to label this as 1 and this one as negative 1. So I start up here at 0, 1, then I go to 90, 0. So the 90 is my x value, so I'm crossing the x-axis at 90 degrees, and the y value there is the 0. Then I go to 180, and the y value there is a negative 1. Then it comes back to 0, then it goes back to 1. Looks like a V shape, but the shape is actually curved. So once you take these three coordinates right here and make those look like a symmetric U or like a bowl, and if it's not perfect, that's okay. Obviously mine's not perfect. And then take that same idea and continue that on, just going upside down, going this way. So that graph's going to do that, and the graph back this way is going to do that. So that's what the cosine graph looks like as you travel around the circle one time, and the shape that's being formed there is called a sine wave. We've done one cycle or one repetition of going around the circle, and we're going to talk more about what that means for some of the characteristics of these graphs. Let's do the same thing for sine. As we travel around the circle now and look at all the y values, when we start at 0 degrees, the y value there is 0. So right away, the sine and the cosine graphs start at a different position. The sine graph starts at 0, 0. The cosine graph starts at 0, 1. Now let's keep traveling around the circle. Again, these are all degree measures. So the sine at 90 degrees is 1. Sine at 180 is 0. Sine, or the y value at 270 is negative 1. And then we're back to 0. So now when we graph those coordinates, it's going to look like this, which is very similar to our V shape that we had before for the cosine. The only difference is the V shape starts a little bit later. It starts here, goes down, back up, and our next coordinate would obviously be up here. So this one's a little bit easier to make it look like an actual wave. You're going to have the upside down U shape here, and then we've got our U shape down there, and then the graph continues in both directions. So the sine wave or the sine graph actually looks like a wave. It's got an upper wave and a lower wave before it goes back to its original position. So now let's talk domain and range for some of these graphs. Remember that the domain is the x values. So if you think about as we go around the circle, the x values are the degree measures. And there are degree measures that are in between here that we didn't graph, including decimals. And we could go around the circle the other way and we would get negative answers for x. So the domain is going to be all reals, and that's true for both graphs. So you can take the sine or the cosine of pretty much any number you want. When you do the range, however, the range is the vertical components of the graph, or the y values. Notice that the highest that the graph ever gets is 1, and the lowest the graph ever gets is -1. So the range is from -1 to 1 for both of these. I want students to be careful though, there is an official notation that you should be using for domain and range, and it usually includes brackets. It includes a variable, and then a vertical bar, which we say for that as such that. So we'd say the range of y such that the y values go in between -1 and 1, and then we close the bracket. So the same is true for the for the sine graph. We would say that the range is exactly the same because that graph goes up to 1 and down to -1 as well. And those are the max and the mins of both of those graphs. A bracket y such that -1 is what y is in between. Let's look at the intercepts of the graph. First, let's look at the x. The x-intercepts happen here and here on the cosine graph, and those come from the 90 and 70. So let's just label that directly on the graph itself. Keep in mind that those x-intercepts will be repeated if we were to graph more of this cosine line, and it will repeat every 180 degrees. So the x-intercepts are 90 degrees to 70 degrees, then we're going to put a dot 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 there to indicate that they do continue. They also continue in the negative direction as well. So if we kept going here, our other x-intercept here would be at -90. The x-intercepts for sine are different than they are for cosine. So we do have one difference here, and that is the intercepts. The x-intercepts for the sine graph start at 0, or 0 degrees. The next one happens half a circle later, or half a cycle later, at 180, and then again at 360. So let's label those. 0 degrees, 180 degrees, and 360 degrees. And those also will continue as you draw more of the graph. Again, those will repeat every 180 degrees. But let's put a dot 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 there to indicate that there are other answers beyond what we've written. The y-intercept, it's written here as a plural, but there really only is one. The y-intercept for the cosine graph is at 1. The y-intercept for the sine graph is clearly here at 0. So they have the same domain and range as each other, but the x-intercepts and y-intercepts clearly distinguish one graph from the other. The symmetry is a little bit more difficult to figure out. For now, just watch the screen here. You don't need to copy this. When you graph the cosine graph by just making a sketch, there's one wave of it. And if we do another wave going back the other way, you end up getting, that kind of wavy line. So hopefully you can see here that if you folded it vertically, the two halves would line up with itself. So we call that reflection symmetry. So we'd say that the cosine graph is reflection symmetric. When you give the symmetry, make sure that you say what it's reflected over. So we'd say reflection symmetric over the y-axis. The period is something that we'll get to here momentarily, so we're going to skip that just for now. The symmetry of the sine graph is a little bit more difficult to visualize. What I'd like you to do is, if you've copied this picture on your paper or in your notes, I'd like you to turn it upside down. And when you look at it upside down, it should look identical to the one that I have here on the video. And so the reason why it looks the same is because it's rotation symmetric. So rotation symmetric is what we'll say here for the sine graph. So students will say rotation symmetry or rotation symmetric for sine. The book describes it a slightly different way. The book will say that it's symmetric about the origin, which is the same as saying it's rotation symmetric, just described in another way. Let's fill in period next, and so for that we're going to jump down here to the definition. The period of a sine wave, which means the period of a sine graph or a cosine graph, is how long it takes that graph to begin to repeat itself. So let's take a look at these two example pictures first. This one kind of reminds me of a heartbeat or a blood pressure indicator. EKG. And so you can see that the graph keeps repeating itself. So we would identify the period either on the x-axis here or up above here if we had a scale, that would be the period or the length of how long it takes for that graph to start to repeat. So whatever that measurement is would be the period of this particular graph. Same thing here, we'd look at the x values from here to here and we'd be able to figure out what the period is of this graph because it repeats that V-shaped wave however long that measurement is. On our sine and cosine graphs, we can measure the period by just looking at how the wave behaves. The cosine graph starts up here at 1, it travels down and then back up to that same position after we've traveled 360 degrees. Which makes sense because we go around the circle one time before we start to repeat ourselves. So 360 is the period of both of these. So in summary, the graphs both carry the same name. They're both referred to as a sine graph, or a sine wave, but the cosine and the sine graphs have different x-intercepts and different symmetry. They do share the same domain and range and the same period. When you are asked to graph, you should be comfortable identifying domain, range, symmetry, and all of the intercepts. So make sure that you're studying those elements along with the actual graphs themselves. So sine wave we've already talked about today. That's the shape or the name of either a cosine graph or a sine graph. If the book mentions the word sinusoidal, that's just, again, another way to refer to a sine wave graph. I'd like students to practice sketching both cosine and sine right now. And here it mentions 3 periods worth. So why don't you try that on your own to start with. And so pause the video. And then in a minute here I will have you restart the video and I'll describe how to do both of these. So remember that 3 periods or 3 cycles of the graph is what we want to sketch. So give yourself fairly ample room here to do multiple cycles. And I'm going to start with the cosine graph. The cosine graph starts up high, dips low, and then comes back up. So I want to do that same shape again using kind of the same height and the same width. And that wasn't perfect, but decent enough as far as I'm concerned. I could do another period going this direction, but a lot of times they want you to do a period in the negative direction, so let's try one going back to the left. So I did an okay enough job here. What you'd want to do to finish off your graph is give it some labels. So remember that the cosine graph crosses the x-axis at 90 and 270. You could then figure out additional x-intercept values if you needed to. They just repeat every 180. So if we went back here, we know that this one's going to be at negative 90 degrees. This one's going to be at negative 270 degrees. We could add 180 onto 270 here to get the 450. And we could add 180 on to get to that last one if we needed to. The only other thing we would need to label here is the y-axis so that people know what the scale is. So anyone who looks at this graph without knowing that it's a cosine, anyone who looks at it who knows their cosine and sine would be able to tell fairly easily that, oh, this is a cosine graph, it's a sine wave, because that's the shape of it, and it's reflection symmetric about the y-axis, and I can clearly see that it's cosine because it has x-intercepts at 90 and 270. Pause the video now and try the period of sine if you haven't done so already. Try to do 3 periods of that one on your own. Pause the video to do that. If you're back from pausing, let's go through the steps for graphing or sketching 3 periods of the sine wave. So again, just give yourself an x and y axis. Remember that the sine wave starts up high, then goes low, and then back up. And I did that kind of big. I want to make it a little smaller so I don't run out of room. So I'm going to do that same shape again 2 more times, making sure that the space you have between the bump and the x-intercept is kind of the same, and that you're traveling up above and down below about the same amount as well. Then I'm going to go ahead and do another one back here. And so now I've got my 3 waves worth of sine. Let's fill in some x-intercepts on this one as well. It's going to cross at 0 degrees, 180 degrees, and at 360 degrees. Make sure you label the y-axis as well. Anyone who knows their sine graphs would be able to tell that this is 3 periods of the sine wave.